What's up, guys? I decided that I was going to take a pause today. So, welcome to Wednesday, April 1st. I decided to take this pause because I wanted to go over the worksheets with you. So, you went over mitosis, asexual reproduction. I think you touched a little bit on meiosis. I was going to do the steps today, but the steps will be done tomorrow, so Thursday instead of Wednesday. So when you see my video, it's going to say, welcome to Wednesday, April 1st. It's not. Welcome to Wednesday, April 1st. So without further ado, I want to go through these worksheets. I noticed some of you were doing them and some of you were not, and I want to make sure that you guys understand what's happening with these. So we'll start with the types of asexual reproduction. That's this one. We have an example here. This is going to be probably binary fission. Could even be mitosis if that was a choice, but it's not. And this could be an amoeba. This could be a bacteria. This one across here, this is going to be budding. You could see the unequal division of the cytoplasm. And a yeast cell or a hydra would be an example there. Over here is sporulation. You could see it. And that would be fungus. Over here you would have regeneration. And this would be like a starfish. Could even be a lizard's tail. This is parthenogenesis. I don't go over this. But genesis. I know some of my research students know this is a, what do they call them? A water flea or something like that. And that's a Daphnia. They do that. And then lastly, vegetative propagation. And that's in plants. Okay, the parthenogenesis, you're not gonna see that on any exam or anything like that. With the comparing mitosis and meiosis over there, I have to actually just transfer it because I redid that. I just gotta find out what number this one is here. Number 1, review of mitosis and meiosis. What is it, that one? Oh no, I didn't want to do that one yet. Sorry, guys. I'm gonna make sure I'm in the right spot here. All right. I had that already? No. Okay. Here we go. So then we have the reproductive systems. I noticed a few of you were getting some things wrong here, so I just wanted to go through those quickly. Over here, for number 1, this is the ovary. That's where the eggs are located, and this is number 1, female reproductive system. It's called an anterior view or a front view. Over here it's called a follicle. That's what develops the egg. I probably should have given you that one, but the egg actually develops inside of sort of this, it's like a surrounding cover. Here is the egg cell itself, and when that comes out during ovulation, you have it goes out into the oviduct, or another word for that is the fallopian tube. Same thing, 2 different terms. Over here we have the uterus. This is where the embryo will develop. Then it'll turn into a fetus. And then once it's born, it's called a baby. You don't have a baby in the uterus. It's a fetus. Over here is the cervix. So that keeps the uterus closed. So if you've ever watched any TV shows and they're like, oh, you're 9 centimeters or whatever it is, that dilation is the cervix. It opens so that the baby can come out. Here you have the birth canal. And then this would be sperm that has entered the birth canal. All right, jumping to number 2 over here, female reproductive system. We have over here, this should be, and this is a side view now, lateral view. This is the ovary. It produces the eggs. Number 2 is the oviduct or the fallopian tube. Or fallopian tube. Implantation occurs in the uterus. The cervix is at the end of the uterus. And then the vagina would be your birth canal. All right, the big things here, the uterus, that's where the embryo and the fetus will develop. The oviduct, that is where the egg will be fertilized by the sperm. And the ovary is what's producing eggs, as well as hormones, the estrogen. Male reproductive system, pretty simple. The biggest thing that we need to know here would be the testes. They produce the sperm cell. The scrotum is over here, that's number 2. That keeps the testes at a lower temperature, otherwise the sperm can't survive. Over here, we have a couple of different names here. We can call it seminal, vesicles. I've seen them called prostaglandin. I mean, I've seen tons of different names. So we'll just put it seminal vesicles, and that provides the fluid for which the sperm to survive in the birth canal. Over here is called the vas deferens, and the sperm just comes out that tube into the urethra, which is number 5. Urethra. Holy moly, why did I do that? Urethra. And then the male sex organ, number 6, the penis. You'll never get a question on that on a Regents exam. All right, so I went through those, and then my big one that I want to go through with you was this one over here. Okay, because I saw a few of you getting some things incorrect. The number of chromosomes found in every body cell. This is the diploid number. That's every body cell. So for a human, the diploid number is 46. Chromosomes similar in shape, size, and function. Comes right out of the notes from yesterday. These are called homologous chromosomes. And this one is review of mitosis and meiosis. And I put on there N haploid, 2N diploid. 3, half the characteristic number of chromosomes is called, that's going to be the haploid number, half the number. Number 4, what type of cell contains 2N? I have it on top of the page. That would be the diploid, which would be body cells, skin cells, immune cells. They're all 2N. Which types of cells contains the N number? Those are the gametes, also known as the sex cells, also known as the sperm and the egg. Which contains pairs of homologous chromosomes? That's going to be body cells, also known as, over there, 4 diploid cells. All right, over here, I saw some crazy math going on. It shouldn't have been too hard. I did the first one for you. If our 2N number, our body cell number is 46, that's the same as diploid. So ready? Put in diploid. If our N number is half of the diploid, or half of the body cell, then that's 23. That's the same as what's in a sperm or an egg, which is the same as a gamete, which is the haploid. So the diploid and the 2N straight down should be the same. So if we looked at the chicken, we know that's 42. If we looked at the fruit fly, we know that's 8. Diploid and the 2N are the same. If we looked at the rat, the N number is 3. That means the number of sperm and egg chromosomes is 3. The gametes is 3, and the haploid is 3. So those 4 columns, 1, 2, 3, 4, should be the same throughout. Right? So you have 28 for the elephant. 28 is the N number. 28 is the number of chromosomes in the gamete, and 28 is the number in the haploid. Of the haploid. In the haploid of the haploid. With the worm, 900. So that's the N number is 900, and the gamete is 900, and the haploid is 900. In the ivy, the N number is 6, the gamete is 6, and the haploid is 6. And then the mushroom, the, what is that? The haploid is 11, so the gamete is 11, not the diploid. My bad. There we go. And the N number is 11, and the sperm and the egg is 11. So now we have to double some things, or we have to half some things. So if we look at the rat, if it's in the sperm and the egg, if it's 3, then the 2N is 6, and the diploid is 6. The chicken, the 2N is 42, so we half that. The N is 21, the N is 21, the N is 21, the haploid is 21, the sperm cell is 21, the gametes are 21. The elephant, if it's 28, then we have to double it. In the if it's 28 in the sperm and the egg, we double it for the 2N, and we have 56. In a worm, the N is 900, so then the 2N is 1800. The diploid is 1800. In the fruit fly, if 2N is 8, then the N is going to be 4, the gamete is 4, the haploid is 4, and the egg is 4, or the sperm is 4. Last 2. The ivy, if the sperm and the egg is 6, then we just double 6 for the diploid and the body cell, or the 2N. And then same with the mushroom. If it is 11, then we just double that. We end up with 22 for the diploid. I didn't do that last one. Which cell only contains one member of each pair of homologous chromosomes? Sex cells, or gametes. All right, so that was a review. We have covered, if we go through and we looked at my notes over here, We covered mitosis versus meiosis. Mitosis, asexual, identical. You have daughter cells that are identical to the parent cell. Meiosis, that's sexual, making the sperm and the egg. You're halving the number of chromosomes, so they are not the same. It provides variety, and you'll see that on Thursday. The term half the number of chromosomes is haploid. That is a gamete. That's a sex cell. That's a sperm or an egg. Diploid is a body cell. And a chromosome is just a tightly coiled piece of DNA. It's found in the nucleus. You have 23 chromosomes in your body cells. Half come from mom, half. You have 23 pairs of chromosomes in your body cells. Half come from mom, half come from dad. That equals 46 total chromosomes. It's amazing. Like, it's a good thing I'm listening to what I'm saying. Otherwise, this will be on the air forever. Homologous chromosomes, these are identical or similar, pairs of chromosomes. They are similar in structure and function, and one comes from mama, one comes from daddy. All right, so that's a recap of what we've done this week. Today is now Wednesday. That was 3 days. I went over the worksheets that you had. You should be able to fill them out if you haven't already. And you guys should just keep up with it because you're going to need to know this stuff anyway at some point. And I'm trying to make it as easy as possible. Have a good Wednesday. See y'all later. Peace.